What's good, Logan? Coming at you with another video. So what we're going to do here is we're going to try to solve this polynomial. And what we have to do is we have to use the rational root theorem. So when we look at this polynomial, the first thing that we notice is that it's not going to factor using grouping. So there is no common factor here and common factor here that's going to result in a binomial that we can actually factor. So we're going to have to use the rational root theorem. So first thing I'm going to do for rational root theorem is I'm going to figure out all the factors of 24. Then I'm going to figure out all the factors of 5. So let's start it up. Let's start with that 24 right there. So the factors of 24 are as follows. The first one is 1. So 1 times 24. I like to put the numbers separated like this, and then they kind of just, they order themselves out. After 1, we can divide by 2. 2 times 12. So after that, we got 2 and 12. Next, we've got 3. 3 times 8. And then we can go with 4, and that's 4 times 6. And then after that, you'll notice that the group or the sets of numbers, they pretty much kind of fill themselves out. Now, obviously, 5 is not going to work, and it's not always going to be 1, 2, 3, 4, of course. But in this case, it happens to be. Now, there is nothing that goes there, and then I'm going to factor out the 5. So now I factor out the 24, then I factor out the 5. This here, I only have two factors, 1 and 5. Now, what the rational root theorem says is if we take one of those blue numbers, the 24, the 12, the 8, the 6, the 4, the 3, the 2, or the 1, and we divide them by 1 or 5, that will give us something that if there is a rational factor, then it'll be that. All right, so now what we're going to do is we're just going to kind of pair up the numbers, the blue numbers and the red numbers, and we're going to just try dividing. So we're going to take the polynomial that we have, 5x to the power of 3, and we're going to write out the coefficients. And all we're going to do now is we're going to apply what is it called? The factor theorem. And the factor theorem states that if you divide the polynomial, then what you are dividing by is a factor if the remainder is 0. So we're going to set it up, and now we're just going to kind of test numbers to see if we can get something to have a remainder of 0. I'm going to do 1 divided by 1, so I'm going to take the blue one and the red one, so 1 divided by 1, and I'm just going to check to see if that works. So we're going to test to see if 1 works. 1 times 5 is 5, 5 plus 7 is 12, 12 times 1 is 12, 58 take away 12 is 46, negative, and then we have negative 46, and immediately we're like, okay, that's not going to work. So I now know that 1 is not a factor, so 1 is not going to be a factor. So now I just want to test other values. Next thing I'm going to test is, once again, the blue one over the red one, except this time I'm going to try the negative variant of it. So negative 1, so that's going to give us negative 5, then 2, negative 2, negative 60, and then positive 60 right there. And that automatically we can tell is not going to work. So I'll get rid of these guys over here, and 1 and negative 1 don't work. So I'm going to up the ante, go to 2 now. That's going to be 10, 17, 34. This is going to give us 24, I think, and then negative 24, but then that's going to give us negative 48. All right, so that didn't work right there. We're going to go ahead and get rid of those guys, and we're going to try. So I've tried 1 over 1. I've now tried 2 over 1. Now I'm going to try negative 2 over 1. So all I'm doing is testing numbers out to see what works. This is going to give us negative 10, and then 7 minus 10 is negative 3, and then positive 6, negative 52, positive 104. This thing, right, is not going to work here. So now we've tried 1 and 2. We've tried negative 1 and negative 2, and now I'm going to try 3. So we're going to test 3 out. Let's see how 3 works on this guy here. So we get 15, 22, 66. I just want to make sure I don't make any mistakes here. 5, 15, 7, 22, 66. That's going to give us positive 8. 3 times 8 is 24. Oh, look at that. And we now just found out that x minus 3 is a factor. So because of this, right, we now know that x minus 3 is a factor. But we also know that this guy right here is the quotient factor. Now remember, when the remainder is 0, that means you're taking a look at factors over there. Now you have to rewrite it correctly. So we're going to go 5x squared plus 22x plus 8. All right. Once you get to this stage here, now we're trying to solve it. We need to solve for all the solutions. The good news is we have one of our solutions already. We already found out that x is equal to 3. So x minus 3 is equal to 0, which means x is equal to 3. And then we have to solve the second equation, the second polynomial, 5x squared plus 22x plus 8 is equal to 0, because we're using the 0 product property there. So the 0 from the original equation is still going to be there. All right, this is a quadratic. When you get to a quadratic, you can do either quadratic formula, completing the square, or solving by factoring. So I'm going to try to factor. I always give factoring a chance to see if it works. 5x squared only has 5x times x. 8 has multiple possibilities. I'm going to go with 4 and 2 because 4 times 5 is 20, and I'm trying to hit 22. So that'll be a 2x right there. That'll be a 20x. Sorry, with that guy right there. And that's exactly what we want. We want to add that to get 22, which is perfect. So I'm going to make sure that the signs are going to make sense to get that 22. So we're going to put a plus there and a plus there. And we get 5x plus 2 is equal to 0. And we get x plus 4 is equal to 0. So now we have x equals negative 2/5 because we subtract the 2 and divide by 5, and x equals negative 4. Now, what I want to make sure everyone understands here is that the actual rational root theorem just worked. Because right here, when we have negative 2/5 as one of our solutions, that's because the numerator could have been 2 and 5. So using that 2, 5 right there. And then we can also see that the 4, right, x equals negative 4 as a solution is 4 divided by 1. So the rational root theorem is holding true. I'm just going to write my solution at the very end. X is equal to 3, negative 2/5, and negative 4. All right, if you have any questions, please hit me up by email. Other than that, I'll see you guys tomorrow. Have a great night, and peace.